Hello viewers, in this video I would like to discuss about the polynomial reduction set to 3 set. We know that in my previous video I already explained that set belongs to class NP, and then Cook said that set is NP complete, so I am taking this set to polynomial reduction to prove that 3 set is NP complete. So for that, what we need to do, let's say we have an instance of set that is u equals to x1, x2, xn, and c are the clauses c1, c2, cm be an instance of set. And now we need to construct an instance of 3 set. From the definition of 3 set, we know that 3 set instance has for each clause exactly 3 literals. So let's say ci is the literals yc1 i1 yi2 till yik, where it's limit to 1 to m. Now k is a natural number, and it is calling the literal of a clause. For any clause ci, we are going to introduce a set of clauses which can exactly be set and which can be satisfied if ci is satisfied. So for that, we will introduce one new boolean value zi j, where ji is also belongs to depends on the number of literal of ci. So for this is the first step where we are assuming how we will construct the 3 set from set. And then in the first step what we are doing, let's say I have a clause of set that containing only one literal, the yi1. Then we introduce two new variables, ui is equals to zi1 zi2 to make the 3 set equivalent 3 sets. So ci prime is my new 3 set, and then yi1, or we will introduce for 2, it will be like 2 to the power of 4, means 4 possibilities. So it will be 0 0 0 1 1 0 1 1. That is, here you see that why these many combination can be possible for two variables gi1 and gi2. So yi1 or gi1 or gi2, and this is a conjunctive normal form, so and between and then yi1 zi not or bar, then ji2, and yi1 or gi1 no or not, or you can say bar of di2 bar, and final clause will be yi1 or gi1 bar 1 bar gi1 gi2 bar. Now this is the clause, it will be equivalent 3 set clause. For the original clause of ci will contain this is ci prime, and original clause of set will contain only yi1. It will be ci prime will be satisfied only if ci is satisfied. So we need to assign the values in a way that each clause become 1, and then it will be fulfilled. Now in the next step, step 2, if we have k is equals to 2, then we have ci means set clause will contain two literals, and then we will introduce a new variables that gui is equals to gi1, and then it will be only for one variable. One variable will have only two possibilities. One is zi1, 2 to the power. Uh, so it will be two variables. So gi1 and gi1 bar. Then this is the clause. This clause will be satisfied if the original clause of ci is satisfied. Now if k is equals to number of literals is equals to 3, then ci will be equals to ci. There is nothing we need to do actually, because then both instance, three set instance and set instance will be equivalent. Now if we have a value that is greater than 3, then we need to introduce the new variable, boolean variable from gi ui is equals to gi j, where starting point of 2 to j will be limited to k minus 2. In that case, you can see that we can consider the first value yi1, yi2, and then gi2 first new boolean variable, and then the second row you can see that we are getting gi 2 bar and then yi3 and gi3 bar. So here is my gi 2 bar and here is my gi, so it will be cross, there will be not big effect on this clause because to having it, because our target is mainly to have it's a construction of c three set clause. Now we have gi 3 bar or yi4 and gi4 bar. So finally, if we continue like this, then finally it will be gik minus 2 bar. Next will be ki k minus 1 y k minus 1 and y or ki ki sorry yik. So this is my construction for when my k value is greater than 3. If there is a variable assignment such that all of the clauses in ci here is satisfied, then it is easy to say that the assignment of yk will be satisfied, and if satisfied if ci is satisfied. So same thing. And the step 5, I have showed that if k is equals to 5, then what will be the same construction k. If k is equals to 5, then we will introduce three new boolean variable u is equals to gi1, gi2, and gi3. Finally, it will be and let's say literals of set ci is equals to yi1, yi2, and gi3, yi3, yi4, and yi5. Then we can say that the new clause of 3 set will be equivalent yi1, yi2, or yi or gi 2, and next clause will contain gi2, yi3, and gi3, and then it is like the negation of 3, because here is gi3 and the next clause will contain gi3 bar, yi4, and yi5. Question is, how do we make a satisfiable assignment here? Let's assume the value of variable assignment will be gi3 equals to 0 and yi4 equals to 1 and yi5 equals to 0. Then we will see that it is a truth assignment and it will satisfy the first clause, and a when gi3 I am assuming is equals to 0, then the second clause will be also satisfied, and then finally we will have this first clause satisfied. So as a result, it will be this clause will be satisfied, and then it will be also meaning that the original clause will be satisfied. And the finally we will see that all of you will